sound on. Transition to the gaming screen, and hello everyone. How are you doing, Mama?
Doing all right. How are you this evening?
Doing okay. I think last week I talked about how the floorboards had water underneath them. So,
Got all that fixed
because
and everything's good
it,
again?
it it seems like the problem has been dealt with. There's still water underneath my floorboards, and I don't know whether or not that'll ever go away. So hopefully that doesn't cause mold. But
Yeah, you need to get that dried up as soon as possible.
yeah, so I'll probably talk with my landlord again. Um, because I don't think I can peel up the land boards, the floorboards. At least not on my own. And I don't want to. I mean, it's the landlord's responsibility to deal with that. So, I mean, they dealt with the plumbing, so that part got resolved. There's still holes in my wall, but better than a leak. But aside from that, I don't have anything fun to talk about. So, anything interesting going on your side?
Uh, Really?
Mm. All right. Well, the other thing that happened last week is that we were working on. Hey, Chip Sounder. We were working on Chip Sounder's palindrome math puzzle, and we spent the entire 2 hours trying to figure it out. As you can see in the top right up here. So let me go ahead and read the rules. If I can figure out how to pause again. So this puzzle is palindrome math, which I should probably go ahead and grab the link for. If you want to give this one a go, I'm actually going to call this one very hard. Yeah, this is Palindrome Math by Chip Sounder. Normal Sudoku rules apply. Place the digits 1 through 9 once each in every row, column, and 3x3 box. From either end of the gray palindrome, it will read the same, i.e. row 3, column 6, and row 4, column 7 are the same digit. Cells separated by a white dot are consecutive. Digits in a dotted cage without repeat sum to the total in the top left corner of the cage if given, and cells separated by a black dot has one digit double the other, a 1 to 2 ratio. Clues outside the grid sum the digits along the indicated diagonal, and digits may repeat. There are no negative constraints. Now, normally, we would spend all of the time we can to solve the puzzle. However, because we took 2 hours last week, I spent some time over the week to try and solve this if it was solvable, at least from what I was able to do. And I think I found the solve path. So what we're going to do is we're just going to get rid of everything here. And we're just going to give things some coloring. So first things first, with the palindrome, we notice that we have these 1, 2, 3, 4, 5, 6, 7 cells. Now this red digit actually isn't that important, but we have these 7 cells, because they're in a cage, have to be different, and 6 of them are on the palindrome. So where they reflect is going to be over here. This one's going to be black and orange and purple, yellow, and green. And then next thing we're going to look at is this column right here, because this
Have
dot.
yellow and green reversed.
I sure do. Thank you. This dot right here reflects to this position. So I'm actually going to put a gray X right there to mark that. And so we end up with this chain being sort of connected. So if we were to go 1, 2, 3, 4, 5, that would all work together. So, the other thing is that these two are consecutive, so I'm also going to mark those here. So we end up with a lot of consecutive digits in this column. Another thing is this gray cell. Where does it go in this box? It cannot go here, here, or either of those two, so it ends up in one of those two positions. Eventually we'll learn it does not go here, but we will need to go through all of that first. So let's just sort of look at how this would work. If I were to put a 1 here, this would go to a 2, a 3, a 4, a 5, and a 6. If I were to put a 2 here, this would go to a 4. It could not go down to a 1, because if it did go to a 1, this would be a 2, and then I'd have two 2s. So that's not allowed. So if this is a 2, it must go up to a 4. It cannot go down to a 3, because then it would have to go down to a 2, and we'd have two 2s. So if this was a 4, this goes to 5, 6, 7, 8. If I place a 3 here, this would double to a 6, and this would go 7, 8, 9, and I'd run out of space. So that cannot be a 3. And if this was a 6, 5, 4, 3, I'd duplicate the 3s. So I know this one cannot be a 3. If I start with a 4, this would have to double to an 8, and then I would go 7, 6, 5, 4. 7, 6, 5, 4. If this was a 4, it could... Yep, duplicate the 4s. 8, 7, 6, 5, 4, and another 4. So 4 would have to 2, but then 2 would have to go 3, 4. It couldn't go down to a 1 because we didn't end up doubling the 2s. So 4 doesn't work at all. 6 and paired with 3 would end up with 3 could not go down because that would be 2, 1, and I'd run out of space. Or we'd go up 4, 5, 6, and then we double our 6s. And then finally an 8, and then we put a 4 here. We could try to go down 3, 2, 1, run out of space, or up 5, 6, 7, and then we duplicate our 8s. So that means that this cell here must be 1 or 2. We've covered all of the possibilities for this black dot. And what the left side could be. And so since we covered all the possibilities for the left side, we've covered all the possibilities for the right side. We didn't cover 5, 7, or 9, but those don't work on a black dot. They are all odd, so they have to be doubled, and they double to 10 or more. Okay. So now what about this cell reflecting over here to 4, 6, this one reflecting to 3, 5, and now this 4 or 6 could be a 2, an 8, or a 3. Now, I said earlier that this cell could not be gray, and to show that, these two have to be the same. And the only way that these two could have been the same is if this was a 2. So if this was a 2, this would be a 4, this would be a 5, this would be a 6, 6 would reflect to 3. And so this cell cannot be that one. So that proves that this one is gray 1 or 2. So now I want to add in this orange and black consecutive pair. What can those be? 1, 2, 3, 4, 5, 6, 7, 8, 9. However, we know that these two see this entire set of digits. And so, if we were to start with this 1, it would go 1, 2, 3, 4, 5 for this all the way down. And that sees both of those. Because the gray cell is in the same box, but down here. And if we started with a 2, it would go 2, 4, 5, 6, 7. And so all 5 of those see these two. We don't have a 1 in both, we don't have a 7 in both, we don't have a 6, and we don't have a 3. So 2, 4, and 5 get removed from these. 2, 4, 5. And that also means that 1 and 3 get removed. And the next thing is these two, 6, 7, 8, 9. And then, how do I prove what those can be? So this is where we start by diverging the puzzle. So there are two possibilities for what this puzzle could be. I'm going to go ahead and put in the superscript 2, 4, 5, 6, 7, 8, and then remove those from the center cells. And we are going to focus on 1, 2, 3, 4, 5, 6. Or wait, well, there's a little bit more I can do before we get that far, but it is just going to be easier if I diverge the puzzle here for now. Because what do these end up being for this column? Because we know that 2, 4, and 5 gets removed from all of them. And this one here cannot be a 3, because this one is a 3, or this one is a 3, and so it sees a 3 either way, so that's not a 3. This one is a 6, or that one is a 6, so this one isn't a 6 either way. And either this is a 1, or I think I have to prove what those have to be and how that affects this. Before we get proving ones have to go into those two. So if I look at the let's look at the superscript first. If there's a 7 here, these would end up having to be 8, 9, which makes this 1 or 7, and then this one a 3. And since that's a 7, that ends up being 1. There we get our 1 in either position, so this one cannot be a 1 up here. So 1 has to be one of those two cells. And then I want to look across here, especially at this cell. What can this one be? If we are looking at the center script, 1, 5, and 6 all get removed. This one's a 4 in center script, and this one is a 3 in center script, so 4 and 3 get removed. And in superscript, 2, 7, 8, 3, 6, and 5 all get removed, so does a 1. So that one's 4, 8, or 9, except we know that black and orange are 8 and 9 in superscript. So we actually show that this one's a 4. So we end up with a 4 in either of those two positions, a 3 in either of those two positions, which actually is a 3 in one of those two positions, which I think just proved that one. And then the next thing is I want to look at orange and black and ask the question, can they be 7 and 8? Well, if they're 7 and 8, look at these 3 cells. We know that this one cannot be a 3 in center script because it's paired with a 4. So this one has to be 2 or 8. If this is a 1 in center script, that one can't be a 1. So we end up with the 2, 7, 8, and 9 paired here. If I use 7 and 8, then this one is 2 or 9. This one's a 2, so this one would be a 2. This one would be a 9, but 7 and 8 would be here as well, and so this would be a 9, and so would that one. So we know that this has to be 6 or 7, or 8 and 9. So then I ask, what about 8 and 9? If I look again at these 3, 8 and 9 would make this a 2, so these are both 7, 8, 9. But this 8, 9 here and this 8, 9 here removes 8 and 9 from both of them, making them both a 7, which is not allowed. Therefore, in center script, these two have to be a 6, 7 pair, which is going to remove 7s from these two. It's going to remove 6 and 7 from this one up here. And we end up with that being how things are. The 3 here takes the 3 out, so we have an 8, 9 pair there. And we have a little bit more things to do, but we do see that 2 has to be in the middle of this row, because it's either here on the right, here on the left, or it's in the superscript version. So what does that mean for the remainder of this row? Well, 1 and 2 get removed, 4 and 3 get removed, 6 and 7 get removed, and then if we look in the superscript versions, 4, 2, 3, 6, 5, 8, and 9. We have a 1, 7 pair remaining. Okay, and then we want to look at these 3, especially this black dot right here. So 1, 2, 3, 4, 6, 8. If we look at the superscript version, 1, 2, 3, 4, 6, 8, we know that 8 is removed for the 8, 9 here. 2 gets removed from this one, and so 4 no longer has a partner, and neither does 1. So in superscript, this has to be a 3, 6 pair. And this 6 right here means the top isn't a 6, and so the bottom is. And notice in superscript that this 6 would pair with those 2, and also this one here. So we have that one is 6 in superscript, and this one is 3. That means yellow has to be 2 or 4. And again, in superscript, we cannot use a 2. So we learn that yellow is 4. What about the center script? Well, we have a 6, 7 pair here. So 6 and 3 get removed. We already have a 1. So 1 gets removed, and so we're left with 2, 4, and 8. One of them has to be a 4. So what is left over on the yellow square? We have 2, 4, and 8 are all even, so we must use odd digits, 1, 3, 5, 7, and 9. Well, 6 and 7 pair to remove the 7. And I still have 1 gets removed because of the 1 here. So I still have 5 and 9 that I need to get rid of. However, I also see that the 4 over here sees the 4 here, so that gets removed, and actually proves that this one has to be a 4. And where do we see 4 in center script? We see it here, so that proves that this one has to be purple. Removing the 4 from the green removes 5 from yellow, so we have to decide whether that is a 3 or a 9. And the way we do that is we look at this diagonal here for 38. Let's start with superscript, just because it will be a little bit easier. And if we look at our superscript, we have 3, 6, 4, and 4, 6. And we have 1 or 7 remaining, and so we just need to figure out what these two are. And if we add all of these up, that is going to be 6 and 4 go like that. 6 and 4 is 10, double that for 20. 3 makes 23, and then we have 1 or 7 remaining. If I add a 1, that's 24, and then I would need 14. That would be 5, 6, 8, 9. And if I used a 1 instead, then that would be 24. Excuse me, 1 was what I already did. If I used the 7 instead, then that would be at 30, and I would need to make 8. I'm going to use center script for the 8 marking for a second. Actually, maybe I shouldn't do that. Let's do it in these two. So 8 would be 1, 2, 3, and 5, 6, 7. Okay. So, if I want to make 8, then I see that in superscript, the 7 is what forced an 8. So I would end up with a 1 and 2 here. So 1 and 2 would get removed, 7 would get removed, and so with 6, I have a 2 over here that looks at this one. So that's 2 and 5 getting removed. And what else did I have? The 5 that looks at both of these. So that's the 3 and the 9 getting removed. And okay, so just going to add a 7 and a 1, 3. I feel like I could have done more here. But I guess we'll figure that out here in a second. Because I should be able to show that I have to get one of these as one of them. Because if I put a 1 here, then I need 14. If I put a 7 here, then I need 8. Well, this digit here would end up being 5, 6, 7, 8. Aha! And if this and that are the same, then there's no 5, which means no 9. 14 would be 6 and 8. And the 5 also removes the 3. So I have a 1 here, or a 7 there. And since that's not a 5, then 5, 6, 7, 8, 9. And if we have 7 and a 1, I guess another thing that might help is the yellow and green. If we look in this column, where can yellow and green go? Well, we know it's not in box 2. We know it's not here. And we know it's not this one or this one. And it can't be this one because it mirrors up to there, so we get a yellow-green pair. Which we know that yellow and green in superscript is 3 or 4. This 4 would make that one a 3, therefore this one would be a 4. And the other thing we know is that The other yellow-green is one of these two. And in superscript, 3 or 4 can't be this one. So that would be there, but we would have to prove that for the center script version.
Well, 3 is
And
green.
right, but we haven't proved it for both yet.
Right. True.
I forget how to finish this one for superscript, so I think we're just going to move on for a second, and we're going to
Well,
look at
if it was 1 at the bottom, then we need
yes,
14.
yes, 6 8.
And the only way is 6 8.
Yeah, because the 5 here removes it
Right.
from both this one and this one, which is that one.
Right.
But if this is a 7, then I need the 1 and 7 here. And that would put a 1 here. But I don't remember why this one can't be a 1. I guess the other thing I could go ahead and do quickly is fill in this box. Because I can do this for both the center script, because 5 and 6 and 2, 8, and 9 and 1 all get removed. And in superscript, 7, 8, 4, 2, 3, and 1 all get removed. And if I pay attention, this 6 and that 6 remove 6s from here, so this one ends up being a 6 because of the 5, 9 pair. And so this one ends up being purple. Because I also need to look at the 3, 4, 7. Well, the 4s also get removed, so then that's a 3, 7 pair. Because purple is proven for both sides. And now we can look in here, and we can ask the question, what is remaining? For the center script, that's 5 and above. For superscript, it is going to be 1, 3, and 7, 8, 9. And a 3 here in superscript takes it out of these. And the 8 in superscript takes it out of here, and we leave 3 and 8 in superscript. 1, 7, and 9 are going to take the 9 out of this one. Therefore, the 5 is out of this one. And in center script, we lose the 6 from this group, meaning it has to be over here. And we don't know about the 3 and the 7 of how that one's going to organize quite yet. But that does stuff in the row. So let's start with go ahead and do box 9. In superscript, we have, there we go, that's all the digits, 6, 8, 9, all removed. We also have 7 removed and 4 removed. So we have 1, 2, 3, and 5 remaining. And in the bottom, we lose 1, and we lose 5, and we lose 2. So that's 3, 4, and 7 remaining on the bottom row. And that is what takes the 7 out of this one, which I took a lot of effort to do, which I didn't need to, I guess. So that's proven to be a 1 now. And then we also have this one, which the 1 gets removed. 7, 8, 9, 4, 6, 5, 7, and 2. 3 and 1 get removed. So 8 and 9 get removed. And because this is a 1, we lose the 7 and the 1, and that has to be a 6, 8 pair. Since this would be even, this one has to be odd.
And column 5 now has a 6-8 pair in superscript.
It does. So that is going to do the 8 and the 9 here. Okay, so now we have this diagonal pretty well situated for the corner script. Now I want to ask about the center script. But let's go ahead and fill in this corner here, because we have a decent amount. 6, 7, and 4 all get removed. In the top row, 5 and 6 get removed as well. 5. And in the bottom row, we lose 1. So that one's still a little crowded, but we can probably add some things in box 8. So if we go across the top row here, we lose 4, 3, 5, and 6. And in the bottom row, oh, we lost 1 as well, because of the 1 here. In the bottom row, we have 1, 3, 4, all removed. And okay, I think we get more once we look at this diagonal. All right. The thing that we want to look at for the diagonal is these 2 yellow squares. 9 is pretty big. So let's look at what we have if we put 9s there. Because in purple, we have a 4. If we have a pair of 9s, that's another 18. We have another 4 here, and we have 5, 8, or 9. What would we have in these two? Because we have a 5, 8, 9 here, and we have another 8, 9 up here. So already, 2 4s and 2 9s is 8 and 18, which is 26. 5 and 8 is another 13 on top of 26, which is already 39, if I did my math correctly.
Yes. So you cannot have 9s in yellow.
So what that does is it shows that we have to have a 2, 3 pair here. So this is 2 or 3, and this one would be 2 or 3. And we see the 2 is here, so the 2 gets removed, so that's a 3. Therefore, this would be a 2, and we can remove 2s from all of those.
And now the yellow-green in box 5 is 3 either direction.
And it is. And I want to also look at these 2. Because we now know that these 9s are instead 3s. And so what do we have remaining here? In fact, we know that these are minimum 4. Because 1, 2, and 3 see both of them. 1, 2, 3. So these are already a minimum of 9. And what does that tell us about this square right here? Well, if we've got 9 and 14, that is 23. Add an 8, and that is 31. And I need 38, which is a maximum of 7. So my 8 and 9 get removed. So this is now 1 or 5. So I can take 5s out of all of these. And I get a 2, 3, 8, 9 across the bottom. So 8 and 9 get removed, and so does this 3. So then the 7 gets removed. We get a 5, 6 pair here. 5 gets removed from this one. 2, 8, and 9. And that's 7, 8, 9 there. And cool. All right. So now we have 2 7s is 14. A 9 makes 19. And so if I have 19, then the rest of the diagonal needs to be
19.
Yes. And so if I have a minimum of 9, then this could be 8 or 9. So if this is an 8,
10 or
these would
11.
sum to 10. So I lose 7, 8, and 9. So we have 4, 5, or 6 required to be in here. And now I ask the question, where is the other yellow-green in this set? Because it's not in either any of these, because the yellow-green here, removing it from this, the yellow-green removing it from those two as well. And so yellow-green has to be here. And so this is 2 in the center script, but also notice that in superscript, this is the only spot it can be as well. And because it is both 2 and 4, this one ends up being yellow or green in both sets. And also notice that these have to be opposite colors in the 2 groups, because the 3 is in different versions. But what that does also mean is if we look at purple, these 2 right here mean they have to be in here. And it's removed from this by this one removes it from those 2. We know that purple is not yellow or green because purple's this one over here. So it's neither of those 2, and therefore purple has to be one of these 2.
Now,
what does that mean for the
that 4,
center
5,
script?
6, since the 8 or 9, and we need 19,
Yep.
9 would be 10, 8 would be 11, 4 or 7. So couldn't that be 7 also? Instead of 5,
What could
6?
be 7?
Those 2 in the box 5?
Um,
4, 7 for 11 with the 8?
Right.
Or
No. Because, well,
if it's 7, oh, I see why.
So we've got
Oh, no.
14 and 5 is 19, and 8 and 11 would work. However, or no, it's not going to work because the minimum is 36. Because 2 3s and 2 4s is 14. And 5 is 19. Add 9, that's going to get us to 26. So that's this one, that one, the 9 here, the 5 here. Apparently I can't do math, because this is now telling me 28.
Yeah. Well, because 19
2
and 9 is
3s
28.
and 2 4s. Right. And a 5 puts me at 19. Plus 9 is 28. And an 8 is 36. I can only go 2 up from the minimum. But yeah, it was 19 when I just had these.
Right. You need 19 as the sum for the last 3. One of them is 8
Yes.
or 9. If it's 9, they sum to 10, which would have to be 4, 6. If it's 8, they have to sum to 11, which would be 5, 6 or 4, 7.
36 is the minimum.
But black is 6 or 7.
Oh, right, 4 and 7. Okay, okay, yeah, yeah.
So if it's 7, well, if it's 4, it would be fine.
Well, one of the things we know is that a 4 is required
Right.
in in
So it's
in
6 or
here.
7 is the other.
So yeah,
So 5
so the
goes away.
5 gets removed. And so we get 4 and paired with 6 for the 9, and 4 paired with 7 for the 8. And I think that ended up messing with what I had, but let's see what happens. 4, 6, and 7 paired with an 8. So 4, 6, and 7 would be 3, 5, 7, or 6, 8. 3 we know gets removed. And then so this would be the same set, 5, 6, 7, 8.
Right. And the dot in row 3 or in box 2 cannot be 6, 7 because that would break black.
Correct. Um,
So the
which
right
means
one
the right
cannot be
one.
7.
Uh, right. Because if this one's a 7, then this would have to be a 6. So that 7 gets removed. If this one was a 6, this one couldn't be a 5, because then that would have to be a 5. And then 4 and
And
5
can't
and 9 would be not enough, would be 18.
and it can't go to 7 because there again it would break black. So that
Yeah.
one can't be 6.
So this one is now 5 or 8.
And so is the other tip.
Right. And now in the superscript version, just because we're on the same spot, this one cannot be a 9, because if it was a 9, that would break, we would have to pair with an 8, which would break the 8 or 9 in superscript. So 9 gets removed. And 7 gets removed because of this one. Looks up here, says those aren't 7s. So 5 can't go to 8. And so that gives us those in the superscript version. And so all of this gets removed because none of that was relevant to that box. It was just helping us do the math here.
Column 7, the 5 in box 6 looks down.
Yep, that's going to do those two. And that's that for now.
The 3 in box 2, it's column 4, has a 3 in it. The green superscript is 3, which
Right,
looks down.
3 and 1. Let's see. What else can we do with the center script?
Yeah, sorry.
Because I think that's the one where, yeah, I think I neglected that these could be 7s, and so we've at least got this far. Oh, apparently this one. Yeah, the 2, 3, 8, 9 means that's a 7, which means 7s come out of these. 5, 8, and 9 means this one's the 2. And that one's 3. But 5, 8, and 9 gives us a 6, 7 pair here.
Oh, yeah, that 3 in row 8 sees
3 in
box
row
9.
8.
That's 7, sorry. Up 1.
Right, and then those two get removed. And then I want to look at this dot real quick. In center script, 2, 3, and 5 all get removed. Therefore, 1 doesn't have a partner, and neither does 4. So we have 6, 7, 8, and 9 remaining there. Chip Sounder says, now pencil in row 3, column 3 in the center. Let's do that one. 6, 7, and 4 is all gone. 5, 8, and 9 is removed. And so is the 2.
And the 3.
The 3 from right beside it. That's a 1. And let's do superscript just because we're right here. 8, 9, 3, 4, 6, and 5. And 1 and 7. So that's 1 or 2. And guess what? That one is gray. In either case. And then if we look at the center here, 6, 7, 1, 4, 5, 8, 9, and 2. So that's a 3. And in superscript, just because we're right here as well, 1, 4, 8, 9, and 3, 7, 5, and 2. And Chip Sounder says, is this now broken because of the killer cage? And yes, that is correct. The killer cage here, this 21, how do we make this one work? Well, we have a 1 and a 3. Then that has to pair with 8 and 9, and 6 and 7 isn't 8 or 9. So the 21 doesn't work. So I didn't need to prove all the way exactly. So we know that the center cells are all wrong, and we just have the superscript. 2, 4, 5, 6, 7, 8, 2, 1, 5, 3, 4, 6. In fact, 6s are all here. This one's just an 8. That's a 4. 4, 3, 4. 4s are yellow. 3s are green. 2, 5, 1. 3 gets removed. 4 gets removed. 2, 7, 5. That's not correct. 3, 1, 8, 9. Loud sounds outside. I don't know if that's picking up on the microphone at all.
I don't notice it.
Cool. And then we have an 8, 9 pair. 3, 4, 6, 5, and 5. And that one is purple.
And the little killer you can complete in row 3. Or not little
Row
killer,
3.
the killer cage.
Right, because we
21
have
cage.
2, 4, and 6. So we must have a 9 remaining. And so 8 is orange. And then we just finish off the puzzle. I still need a 1, and I also need something else.
2,
2 can be
5,
anywhere.
7, 9.
2, 5, 5, 5, 9, 2, 5, 7. 2, 5, 7, and 9. 5 is removed. And then 1, 2, 3, 4, 5, 6, 7. None of these are a 4, so that is. This one isn't a 5. 1, 7, 9. 1, 2, 5, 7, 9. 1 and 5 gets removed. 2 would have to pair with 3, but that 3 over there says, well, that there's a 3 in the box. So 2 can't pair with 1 or 3, so it's not allowed. Therefore, this is 6, 8, or 9. I don't know why I'm trying to say it's 9. It has to be even. This 6 over here says it's not, so that is an 8.
Row 6 needs a 5.
6.
Where's the 5?
5 has to be, because we've got 1, 7, and 9. So 7 and 9. And 1 gets removed, so that's 2, 5 pair. 7, 9 pair gives us 1.
7, 9 pair in column 4.
7, 9 pair in column 4 gives us a 2. Let's finish off box, whatever this one is. 6, 5, 4, 3, and 8. And then we have 2 and 1 and 6 and 6 and 2, 6 and 9. Chip Sounder says row 6 in row 4 has to be right here because 1, 7, and 9 pair. Or also the 6 has to be in the top row, and this 6 says it's not there, and 6 isn't a 5, so that we have a 6 here. One of
179
these.
triple.
Yep, to force 2. And then I'm going to look in row 2, just because we've got this box right here that needs something to happen to it. 8, 6, and 3. This one, in fact, I should have just simply looked at these two columns. We've got a 1, 7 here, and 9 and 8, I believe, but this 8 is already seen, so that's a 9, that's an 8. And so we get rid of 9 in the rest of the row. This one sees 2, 4, and 5. So we get a 1, 7 pair, which is going to give us a 3 at the bottom. This one sees 2. This one sees 1 and 5.
There's a 1, 7 in the row.
Pair. And over here. Now 4 and 2. Now whatever this is, it sees 1, 7, 9. It also sees 2, 5, 6, 4, and the 3 from all the way down here. And then I'm just going to go ahead and finish a little bit more. 1, 7, and a 3, I think. This one's not 3, so that is 1, 7, 7, 7, and a pair of 1s. And then 1, 2, 3, 4.
6,
I
and
still
9.
need 5, 6, and 9. There we go. But yeah, even with all of the work done previously, still took me 50 minutes. Knowing the solution. But, yeah. But also trying to explain it, and make sure that it's, fully logical. But yeah, alright. And so now, what we go from this one to Palindrome Math by Chip Sounder. Normal Sudoku rules apply. Place the digits 1 through 9 once each in every row, column, and 3x3 box. From either end of the gray palindrome, it will read the same, i.e. row 3, column 6, and row 4, column 7 are the same digit. Cells separated by a white dot are consecutive, and digits in a dotted cage without repeats sum to the total in the top left corner of the cage if given, and cells separated by a black dot has one digit double the other, a 1:2 ratio, and no negative constraints. Chip Sounder says, I remade it, lol. But yeah, and then here is the link. I'm going to go ahead and call this one Palindrome Math 2, just to distinguish them for the chat and for the video description when I get there. And I also noticed my camera was not fully in the corner, which I decided I liked better than having a little bit of a boundary around it. But yeah, anyway, so put that in the chat. So let's get this one started. It is fairly similar. But I am going to start off by doing the same thing that we did in the last one, which is looking at this set and mark these red, yellow, green, purple, orange, black, gray, and blue here. And blue is going to flip over to this one. And then we have gray, black, orange, purple, green, and yellow, and red. And then, just to make sure I did that correct, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 red. Did not do that correct. I made an assumption, which was very wrong. Red, yellow, green, purple, orange, black, gray, and blue. And then we see that this one is our center. So let's go ahead and mark that with a circle. And we see between blue and the cell closer to the circle, there is a dot. So what that tells us is that those are consecutive, and we have the same sort of pattern we had before. And then just to quickly go through it again, if I could put a 1 here. This would be a 2. 2 would go to 3, then go to 4, then go to 5, then go to 6. I could put a 2 here. I could go down to 1, but then I'd have to go up to a 2, and then I have 2 2s. So that's not allowed. So 2 must go up to 4. If I tried to go down, 3, 2, 1, I'd run out of room. So I'd have to go up 5, 6, 7, 8. I could try a 3. 3 has to double to 6. I could try to go up 7, 8, 9, and then I run out of room because I can't do 10. And I try to go down 5, 4, 3. Well, now I have 2 3s, so 3 and 6 isn't allowed. We'd try a 4. If I half 4 and go down to a 2, well, I can't go down to 1 and then I run out of space immediately. And I can go up to a 3, but then I'd have to go to a 4 and I duplicate the 4s. So 4 can't go down to 2. It would have to go up to an 8. But let's see what happens when we go down. 8, 7, 6, 5, 4. Again, those are in the same box, same cage rather. So that isn't going to be allowed either. I could try 5, except for the fact that it would have to double to 10. The same is going to be true for 7 and 9. They're going to double to something greater than 10. So the last remaining possibilities are 6 and 8. 6 would have to 3, and I'd have to go up because 2 and 1 would leave me without a space. So let's try going up 4, 5, 6. Well, now I've got 2 6s in the cage, and that's not going to be allowed. And if I try 8, well, the same thing's going to happen as before. 4, 5, 6, 7, 8. That's not allowed. And 4, 3, 2, 1, and I'm out of room. So 8 gets removed, and I'm left with 1, 4, 2, 3, and 5. And what does that mean for these two, which are also consecutive? Well, these two see all of these, because they're in the same cage as this one. So we see all of those, and if we start with a 1, 1, 2, 3, 4, 5, 6, 7. Excuse me, that's too many. 1, 2, 3, 4, 5. And if I started with 2, that would be 2, 4, 5, 6, 7. 4, 1, 2, 3, 4, 5 cells. What do these two have in common? Well, they don't have 1, they don't have 7, they don't have 6, and they don't have 3. 2, 4, and 5. Well, these two we know are consecutive. 6, 7, 8, 9 is all that's going to be left over, because 1 and 3 aren't going to be allowed because they're partners. 1 has to pair with 2, but that's not allowed, and 3 has to pair with 2 or 4, neither of which are allowed. So the remainder is 6, 7, 8, or 9. From there, what is left over in this column? Well, we know that 2, 4, and 5 gets removed. And we also know that 6 and 7 is going to get removed. Because if I put 6 and 7 here, or wait, hold on. I know that in the bottom that I'm not going to have 6. Because either the 6 is here or it's here. And so there's no 6. But yeah. Okay. This 4, 6 is going to flip over to here. 6 has to pair with 3. 4 pairs with 2 or 8. And so I want to ask the question, which is, where is our gray cell in this box? Well, it's not here. It's neither of those two, and it can't be those two. So what's left over is one of those two. Well, the only way that this and that one could match is if they're a 2. Well, if this is a 2, that's a 4. This is a 5. This is a 6, so that's a 6. Well, if 6 is there, then that's a 3. So these two can't be the same. So we know that this one and that one are the same, and they have to be 1s. that's not true. Because this one doesn't see so I was a little overzealous when I was looking at these. These two only see all of these. They don't see this one. So this one has to be, 1 or 2. There we go. All right. And then we have gray as one of those two, but I'll leave that alone for a second. I want to ask, where is purple? Because these two are 6, 7, 8, 9. What can purple be? Well, let's just simply ask, what can these be? If, 5, 7, and 9 all get removed. This one doubles either to 2 or 1 or 4. And you said green can't be 1. That's very true. Neither can purple. Because if purple was 1, then it would have to double to 2. That would break gray.
Right.
Now, on this black dot, one of them is going to have to be a 2. So I can't put 2 in either of these. Which I think I could have done in the previous one. But yeah, I guess it doesn't matter. All right, so what's left over here? 1, 2, 3, 2, 3, 4, 5, and then 7, 9. Yeah, because it has to be odds. 3, 5, 7, 9 to go with 4, 6, and 8. And then 3 can either be 2 or 4. However, the 2 in the box says that's not allowed. And now this 3 or 5 does something. Because I think it might be a good idea to just simply split the puzzle again. Yeah, this can't be a 2 anymore, because now it does see all of those, which had to include 2, 4, or 5. So yeah, let's just split the puzzle again. 2, 4, 5, 6, 7, 8. 2, 4, 5, 6, 7, 8. And this would be a 2, that would be a 2, and this would be 1 or 4, or it's a 2. And we get a 5 here. We get a 6 there. And so now, 6, 7, 8, 9. This one cannot be 7, therefore it couldn't be 6. And I did that wrong. I did that this way. So 8 or 9 in superscript. So this one would be 1 or 3. 1 or 3. But the 6 would pair with a 3, so that would be 3, that would be, that would be 1, that would be 3. And 3 gets removed because of the 3 there, and the 2 there means that's an 8. So 8 is removed from center script, and so we have to have 8 up here somewhere, but 1 is going to get removed, so is 3. 3 gets removed, so does 1. And we have 7 or 9 down here. But the 8 here means I can't have 8 on either of those, so I can't have 9. 6 and 7 is going to mean that's 9. And so we get 3 or 8 up here in green. So 4 and 6 gets removed. So 3 gets removed, and so does 8. So purple is 4 or 6. And this 6 here means it's not that. And the 3 was in superscript. So 3 pairs with 6, so it's not 4. And that means that these are purple. For superscript 3. Okay, well, 3 is consecutive with 2 or 4. Well, I can't have 2 in here at all, so that 2 is required. So that's a 4 in superscript, so that's a 1. And 8 would pair with 7 or 9, so we give 7 or 9 with a 4,
There's a 6
and I
7
just
pair in the
exactly.
cage.
All right. Red.
Which means red is 3 in center. Oh, no, it's not. I see a 3 there.
Yeah, what could red be?
1, 2,
Because 1, 2, and 3, 4, 8,
5.
9,
It's
6,
5.
7. Okay, and then in superscript, 1, 2, 3, 4, 5, 6, 7, 8, 9.
7.
4, 3, 6, 8, 9, 1, 2, and 5. 5 superscript 7. Okay, where else do we go? Let's finish off box 7. In center script, 1, 8, 9, 5, and 6. And in superscript, 1, 2, 3, 4, 5, 6, 9, 7, 8, 2, 3, and 1. That's a lot of stuff. Is there something I
Column
could
1
do?
has a 4 in center.
Sure does.
That makes that one a 4. 2, 3, 7 go away.
Yeah. In superscript, 4, 5, 6, 9. The 6 gets removed, and then this one would be a 6. And that is purple.
Oh, we knew that just by that it was purple by
Oh yeah.
Sudoku.
Where is purple in here? This one and that one. Say it's not here, not there. And we have purple. Yeah, once we proved that those were the same, then that also removed those. That one. So then that had to be. Alright, what about this one up here? 1, 2, 3, and 5. 2, 3, 7. And then in the superscript version, I still need 1, 2, 3, 4, 5. 6 is there, and 7 is we're missing. 5 is gone from here. Chip Sounder says box 4 is broken in center script. 1, 2, 3, and 4. 2, 3, and 7. 6 and 8. Aha, the 9s. So center script is all gone. 2, 4, 5, 6, 7, 8. 6, 5, 1, 2, 8, 9 pair. 6, 3, 4, 7, 7, 6, and 8, 9 pair. Apparently that's a 1. Apparently this one's a 7. We got 2, 5 remaining. 3, 6, 2, 1, and 4, 5, 9. And I should have. I still need a
Row
1.
8 has an 8, 9 pair.
That's going to give us a 4. 3 and 8 remaining. Chip Sounder says row 5, column 1 would have been a Schrodinger cell. Which is a cell that would have to simultaneously be 2 possibilities, I think is how it's often used in Schrodinger cell puzzles.
Row 8 needs a 7.
I also need 7 and 8, which has to be in here, and none of those are 7 or 8, so that's a 7, 8, and this one tells us it has to be this way. 3, 4, and 9, I think is what's remaining, so 5 and 9 here. 2 and 1, I think, and 3, 4, and 5. None of that is finished quite yet. But let's go across row 6, because we need 1, 2, 3, 4, we need a 5. 7, and 9 is going to be the last one. Unfortunately, not as many things as I thought was going to happen. Let's try filling in our palindrome because 3, 4, and 6 get removed. So does 1 and 2. 7's definitely removed, and 5 is removed. So we have 8 or 9 remaining. Going on to the next one. I see 4 and 3 and 6, 1, 2, and 7, and 5. So we have an 8, 9 pair. 6, 3, 4, 8, and 9, and then a 2. And then going across here, 1, 7, 8, and 9. I also lose 3 and 6, and then the 2. And then the final one here, 7, 8, 9, 1, and 5, it looks like. Okay. Now, I see that this one is across a Kropke. 5 and 7 down here mean this 6 wouldn't have a partner. So 6 gets removed from both of these. And so we get 1, 2, 3, 4, 5. And, well, 1, 2, 3, 4, 5. This one can't be 1 or 5, and this one cannot be 3 or 4, but those two do not have to be the same, so it doesn't really matter. 3 has to be one of these two, so it's going to remove it from this one. 2, 3, 4, and 5 is all a set. So 2, 3, 4, 5, 1, and 7. And since this is 8 or 9, that one's 8 or 9, this one is a 6.
Okay, and that's a 22 cage.
Right.
It just has a 6 in it now.
Yeah.
And it has to have a pair of consecutives, and it can't be 1, 2.
Right. It has to have the 3 in it. Laura Smith says 8 and 9 pairs in column 6 and row 5. Column 6 is going to take the 9 out here. Or row 5 is going to take the 9 out here. Thank you, Laura Smith. How are you doing this evening? What else do we have in column 6? 8, 9, 7, 1, and 2 are all removed. This one's not a 4 because of over here. Laura Smith also says 4, 5 pair in column 8. So we'll take the 5 out of this one, which reflects up to here, and that one's no longer a 5. And 4, 5, 8, 9, 3, and 6. So we have 1, 2, and 7 remaining for the column. And for her row 1, 1, 2, 5, and 7, but there's no 7. Alright, Laura Smith says, doing well. I actually got work hours this week. Nice. It can actually be rather annoying to not have work hours. This Kropke right here looks at this 1, 2, therefore it cannot have a 1 on it. So now the 2 doesn't have a partner. It doesn't have 1 and it doesn't have 3. So 2 is gone. And this reflects over here to take off 2.
Did we get anything else from that cage?
I don't think so yet. Chip Sounders says, can row 7, column 1,
Well, 1, 3, 5, 6, 7 doesn't work. Because you have to have either
row...
a 2, 3 or a 3, 4. Sorry.
Are we looking at column 7, row 1, Chip Sounder? Row 1, column 7. Okay. What were you talking about, Mama?
In the cage,
Mm-hmm.
yeah, 1, 3, the 3 has to be with a 2 or a 4. So 1, 3, 5, 6, 7 doesn't work.
Right. Chip
And it
Sounder
can't
is
have an 8.
asking. Okay, so 8 is gone. So then it has to be 2, 3, 4, 6, 7.
So there's no
Which
5.
means 7, 4, 3, and 2. And then 3, 4 is gone. That's a 3. This is not. That's not a 2. That's not a 3. 5 and 2. 2 is gone. 7 is gone. 3 pairs with, well, we don't know. Well, it doesn't pair with 5, that's for sure. 6. I think we've got a 1 left over. This is a 5, a 7, a 2. 1 and 2. 1 and 2 is gone. 1 and 5 is gone. This one's not a 3. 4, 5 pair gives us a 3, though. 1, 2, and 9. Actually, a 1, 9 pair is going to give us a 2 and a 5. It's going to give us those. This one isn't a 7, 4. And what's left over in this box? 3, 4, 6, 7. And this one's not a 5, so this one is.
Box 4 has a 1, 9 pair, placing a 7.
7. And this one is fixed because it's not 8 or 9. I think it has to be a 1. So that's going to give us these over here. Which is going to give us quite a lot. And 9, 8, 8, 9. Chip Sounder says, I got some extra shifts at work too. Extra shifts can be unnice, depending.
Column 9 is 8 over 6.
8 over 6. The way you phrased it makes it sound like that was a beneficial thing. 1's going to go here. I still need a 3 here. I need a 4 there, and I need a 6. And we're done. Not sure why this one was already liked, but you know what? We got it done. Let's go. This one was much faster. Unless I just ended up clicking the like puzzle that quickly. Anyway, Now we are on to puzzle 3 for today, which is another Chip Sounder palindrome puzzle. This one is
Quiet math.
Yeah. Normal Sudoku rules apply. Place the digits 1 through 9 once each in every row, column, and 3x3 box. Duality line. Digits along a gray palindrome must read the same forwards as backwards, and adjacent digits along a green line must differ by at least 5. Digits in a dotted cage without repeat sum to the total in the top left corner of the cage if given, and box borders separate the blue line into equal sums. Digits on an orange line must differ by at least 4. Yeah, what we see is that this line is going to have to reflect a cross over here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And so this one is going to be our center. Let's mark that. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And again, we have a center there.
The palindrome on the left, if we look at the bottom of it, there's a 14 cage.
Right.
That's also in the top of it a German whisper.
Yeah.
So you either have to have too high or too low. Well, you can't do too high. Well, I guess you could. 6, 7, and 1 would be 14.
But if you did too low, that would be... Well, 3 and 4 is 7. So that's a possibility.
But 7. But you can't put 3 and 4 with 7.
Oh, right. You can't put 3, 4, and 7. Because 7 has to be bounded by 1 and 2. So, but 8 could be partnered with 2 and 3, but that's only 13.
Which 13?
And so you would have to use a 9.
Which would be bounded by 2 and 3, or
okay,
1
so
and
this
4.
is either 1 or 9, with 6, 7, or, and you said,
No.
well,
It wouldn't matter down there. It wouldn't matter in the 14 cage. The order.
because it
14
reflects on this side.
Oh, right. Yeah. I forgot about
You
that
have
part.
1, 9, and then 1, 3, 4, 6, 7. Now, if we look at the 9 side of things, clearly this isn't going to be a 4. It's clearly also not going to be a 3, because 4 would force a 9, and that would be 13. 3 would force an 8 at minimum, which is 12. 11.
6 would force a 3, which you can't do.
Yeah, 6 would force 1. 7 could pair with 2, and 2 could pair with 7. And so we have 7 or 8 and 2. And that That one is here. 2, 7, 8. This 1, 2, 7 is this one. 1, 2, 7. And so this side is 3 or 4 to go with the 1 or 2, and a 6 to go with the 7. So this one, 3, 4, 6. All right, we have 2, 7, 8. Now the 15.
Is also part of a
Right.
German whisper line.
And it's these 3. So I guess I just want to ask the question. If this is a 2, then we would have 7, 8, 9. And, well, we know it would not be a 9, because that one's already a 9. No. If this one's a 2, that one's a 1.
Well, if
It
we
would
look
be
at
the
the
6, 7.
15, if you look at the 15,
Yeah.
if the bottom is a 2,
Yeah.
then you have to make 13, but it's also a German whisper.
Uh-huh. So it'd have to be 4, 9. So then that means this isn't a 4. This one isn't a 1. And so you'd have a 1 here with 6 and 7 surrounding it, a 2, going to 9 and 4. If this is a high digit, that would mean that those are all high digits. This would be a 9, so this couldn't be. So we have 1, 2, 3 here. But we also know that the 9 is surrounded by 2 and 3. So that's a 1, 9 pair. But a 1 would have to be surrounded by 14, which could not be a 7. It would have to be 6 and 8. So 7 gets removed. Which also means the 8 gets removed because somehow this isn't a 1. Because this couldn't be a 4. Because of the 1, 9 pair? I think so. So this has to be 2, this has to be 7, this has to be 6 paired with 1. 6, 7, 1, 9, 4. 13 pairs with 2. That's 2, so this is a 9, that's a 4. Yeah, that seems right to me. Okay, we've got 20, and we've got, I think that's 15, so that's 35. So these two are 10. Laura Smith says 1, 7 in 3, 17 in 3 uses 2 highs and a low in row 9. And this matters for the box 6 whisper over here. So this, Laura Smith is saying it has to be 2 highs. So if I tried to do it with a 9 and a 3, 4 pair, well, that's 7 and 9, which is just short of 17, because that would end up being 16. So 2 highs, 6, 7, 8, 6, 7, 8, 9. This one isn't a 7, 1, 2, 3, 4, not a 1, so neither of these are 6. You'd think I would know the right numbers.
Well, a 4 would require 13, and you can't do that.
Yeah. And a 4 would have 2 9s around it.
3 would
anyway, so-
require 14. You can't do that.
So this is a 2. And to get 15,
Requires 15, which is 8 and 7.
so the 8 goes here, then the 2, then the 7, and then this 22 has 2 and 7 in it. And, well, we know this one is 1, 2, 3, this one has to be a 1, because it's in the same cage. And so now this one, 6, 7, 8, 9, well, it can't be a 6, it's going to have to be a 9, so we're going to have a 3 to finish off the sum. Because it couldn't be a 6 because you'd have 2 ones.
Right.
But yeah, okay, so 7 goes to
So
1, 9, and 3.
yeah.
Okay, these two were
What was the
10, which is going to have to be a 3, 7 pair. So then, 2, 3, 4, 5, 6, 7, 8, 9, 9, 4, 3, 7, and 2. This one isn't a 1. This one isn't 6. Those two aren't 1s. That is a 1. What's left over here? Well, 1 has to be this one, because this one and that one says it's not of those, and then those two aren't 1s. 4, 5, and 6, I think. This one sees 4 and 6, so this is a 5, and these two aren't. What's left over in box 4? 2, 3, 5, and 8. 2 and 8 is gone. 2 is gone, so that's 2. 3, 7
column?
means
Yeah.
5, 8, and 3. 5, 6, 8, and 7, it looks like. 7, 8 is gone, so this is 7. So one of these two is 8, so this one isn't. 9, 4, 2, 1, 7, 8, 3. And 2, 3, 4, 5, 6, 7, 8, 9, 2, 7, 3, 5, 6, and 8, 9, and 1. Well, in this row, I need a 9. That 9 says it's not here. 8, 2, and 7 means it's not here. This 9 and that 9 means it's neither of those two. So that's a 9, and that's not. I also need a 3. This 3 says it's not here. 8, 2, and 7 aren't 3. 9 isn't a 3. And this 3 says it's not here. So those are 3. Or that 1 is 3. 5, 6, and a 4.
And 5 can't be on the orange line because it differs by 4,
Right, and there's
which
already
would go
one
to
in
1 or
9.
9.
So 4 would go to 8. It can't go to 9. 6 would have to go to 2. It can't go to 1. Laura Smith says 7 in column 5. It's not here. It's not here. It has to be in this 15, and this 7 and that 7 means it's neither there or there. So that's a 7. And I need 8 more. 1, 2, 3, 5, 6, 7. Well, 1 and 7 is clearly gone. The 6 in here, and the 2 at the bottom, and 2 and 6 are gone. This 5 says that's a 3, and that's a 5. Because of the 3 here as well. Well, what's left in column 5? We've got a 1, we've got a 2, we've got a 3, we don't have a 4, there's a 5, there's a 6, a 7, so 8, 9. This 8 says it's there. This 9 says that's a 4, so that's a 9. 1 and 4 here. This 8 says no to that, so yes to this. 1, 2, 3, 4, 5, 6, 7, 8, 9. 8, 2, 7, 1, and this one's not a 6, this one's not a 5, this one isn't 3 or 9 from down here, 3 and 9 from this one as well, 4, 5, 6, so these two are 3 and 9.
Row 4 needs 1, 4, and 6.
Row 4, 1, 4, 6, and I just saw this 4, 6 in column 9, so that's actually a 5 all the way up here, which is actually going to give us all of those.
Row 5 needs 8 and 9, and it would be 9 before the 8 going from left to right. Because there's an 8 in column 4. So it would be 9. Row 5. Row 5.
You said 9, 8?
Yeah.
Cool. I missed which row you were
2
talking about.
and 2 and 4. I don't know the order though. Oh, but
This
the
4
2 would be because of the
says, oh, yeah.
cage with the 4. I missed the cage.
I didn't see it either. I just thought you had it fully worked out. I don't see a 2 in this
Apparently
column.
I
This
did.
one
I just
says
didn't
here.
notice the cage that had it worked out.
So I think a 7's left. Yeah. What else is there in box 9? I don't see
2
a
and
2,
6.
but this 2 is going to say it's here. 6 there then. Column 8. 1, 2, 3, 4, 5,
6
6,
and
and
8.
8. and then these two tell us how it goes. So we've got 3, 9, and
7.
and 3, 7 pair. Laura Smith says 8 in column 8. We got that one situated. Let's go ahead and finish off row 2. 1, 2. Got a 3 in the 3, 7 pair. I don't see 4, but this 4 is going to tell us where it goes. So this has to be a 5 then. We've got 3, 9, and 2, I think, is left
7.
over. There's 7 here.
Not a 7 there. Yeah.
I was seeing it in the row. But we've already got 2 and 9 here. So this one's the 3, that one's the 9, that's the 2. This is a 3, 7, 9, 7, and 3. I don't think we ended up using this blue line at all. But that's okay. What's left over in...
Well, row 7 is 5 and then 1.
5, then 1. So 6, then 1 here. And then I don't see a 3 in this box, so that's here, and then an 8. No, there's an 8. There we go, first try. All right. That one was pretty speedy. Moving on to our last chip sounder puzzle for today. Yet another palindrome. Copy and paste. And we have Palindromes with Heat by Chip Sounder. Normal Sudoku rules apply. Place the digits 1 through 9 once each in every row column and 3 by 3 box. Digits along a thin gray line must read the same from either end. Digits on a bold gray thermometer must rise from the bulb end, and digits in a dotted cage without repeat sum to the total in the top left corner of the cage if given. Cells separated by a black dot has one digit double the other, a 1:2 ratio. And let's get started. Okay. I wonder if I have a setting about drawing lines on top of other things. Yeah, draw... I have draw arrows above lines. That didn't help. Chip Sounder says pen tool. While this is reloading, something. Why is this taking so long? Do I not have the purple? I guess I don't have the time visible. That's fine. It's okay. Let's see. I was trying to figure out. Do I have a setting that draws lines on top of other things? Because I do know I prefer a dashed grid. Yeah, I don't think I've got anything else. Alright, well, pen tool it is. And so got that line going through there. And that line going through there. And emphasize that. Okay. Well, with that, 1, 2, 3, 4, 5, 6 means our center is this corner, which I can't mark. Although I guess I could mark it like that. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. So that's the center there. 1, 2, 3, 4, 5. So our center's there.
Okay, the longest palindrome?
Yeah.
The one end is a bulb, the other end is the tip of a fairly long thermo.
1, 2, 3, 4, 5, 6, 7. Look,
So
clearly isn't a 9. One, two, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7. Chip Sounder says this was a really fun one to make. Nice. Okay, well... I mean, I guess I could go this one as well. 1, 2, 3, 4, 5, 6, 6, 7, 8, 9. Which... Well, I guess that doesn't really have anything removed from it. But this is going to be 5 through 8, but 5 and 7 get removed, so this is 3 or 4. This is going to... Well, it actually pushes the 6 up. But if that was normally 5 through 8, this would be 4 through 7, 3 through 6, 2 through 5, and 1 through 4. But yeah, 1, 2, 3, 4, 6, 7, 9, 8, 7, 6, 5, 4. Okay, so that's fine. This could not be a... No, I don't know why I was going to say that couldn't be a 3. This couldn't be a 4, is the real thing, though. Because if this was a 4, that would be a 3, and then that would break. But this is going to reflect to here, 3, 4, 5, 6. And... what else? Okay, 14. What can we remove as options from the 14? I don't think I can do anything from that. Nope. Alright, leave that one alone for now. 24. Can have from pretty small digits, so that being 1, 2, 3, or 4 isn't going to matter yet. Alright, let's take a look at this stop then. 1, 2, 3, 4, 6, 8. 5, 7, and 9 get removed because they are odd and have to double. And if you double 5, 7, or 9, you're going to get a 2-digit number. So none of those are allowed.
Put 8 on the bulb.
That is correct. This one is minimum, maximum 7, based off the length of the thermo. It cannot be a 7 because of the black top, though. Let's see. Those do not have to have a 6 on them, but if I did do 3 and 6, you'd have a 5, 7 here. That would be a 4. You have 4, 8. That 3 would just mean that this one would have to be excuse me. Those two would be 6. So you have 3 here and here. I'm not seeing something break at the moment. Do know that 9 has to be one of these two. And 9 has to be one of these 3. 9 has to be one of those 3. Then 9 has to be one of those 3. Chip Sounder says 7, 8, 9 triple in box 3. That is true, but it doesn't help us quite yet. Because all it does is say the 7 points downward. At least I'm not seeing how it helps yet. Where would the 9 end up in this box? So we know those aren't 9s. But either it gets ruled out of those, and so it has 2 possibilities, or it gets ruled out of these, and then it would have, well, that could never be a 9. So um, 9 has 3 spots here. I think. Not really sure. If this was 3 and 6, that would be a 5, therefore that would be a 4, and that would break. So 3 and 6 is gone. 1, 2, 4, 1, 2, 4, 8. And now I don't think I have anything else. I guess 8 does have to exist in this group, which means 8 exists in this group, which means that can't be an 8. Yeah, where is 8 in this box? Well, the thermo means it's too small. And this is too small for the thermo. Even if we ignore the fact that this can't be an 8, that means it would have to reflect over here because of the palindromes. So this can't be an 8. It must be a 6 paired with a 3. Okay, 6, 5, 4, 3, 2. This is a 4. So we get a 1, 2 pair. 3, 2, 1, 1 and 2, 2 and 1, 3, 2. Okay, I'm going to get rid of the 9s just because it feels a little distracting at the moment. Let's see, what else do we have here? 5, 6, 7, 8, 9. 6, 7, 8, 9. These are 5, 6, 7, 8, 9, but none of them can be 6 because of the 6 right there. These two can't be 5, which means one of those two is 6, so neither of these are. 14. It can't have a 1, can't have a 2,
3 and
can't
4
have a
both
6.
have to appear in there, so it's got to be 3, 4, 7.
So we get an 8, a 9, a 7. 7s are removed from all of these. This one's on a 3, that one's on a 4, and 7's not here, so we get an 8, 9 pair and a 5. So that's 6, 7, 8, 7, 8, 4. This is the 4 there. And I'm going to go ahead and draw the line off of that. Go ahead and remove it from here. Also going to go ahead and remove it from here as well.
Maybe.
Eventually. I think we've got stuff situated somehow. Yeah, 3 and 4. So 7 is there. Okay. Chip Sounder says the dot in row 6. Well, the 3 over here means this has to be 1, 2, 4, 8. I don't know why I typed 7. This 8 says no to this. This 4 says no to that. And I think that's all that says, for now at least. Let's finish off row 1. I don't see a 2, which is going to have to be over here in column 9. So 5 and 6, and this 5 tells us how it goes. Still missing a 4 and 7, 8, 9. The 7 on the top says it's not there, but that gives us a 489 triple. So 1, 2, 3, and 6, and 1, 4, and 5. So 4 is gone, which we already knew because of the 8, 9 here. Hmm.
Column 6 needs 1, 2, 8, and 9.
Oh, this thermo. 1 and 2 are not allowed, so that's a 4, which is going to pair with 2 or 8. This is 2 or 3, this is 1 or 2. Apparently the 2 over here says that's a 3. This is still 1 or 2, though. We're just going to go over here. 1, 2, 8, 9. Oh, the 8, 9 right here says that's not. 1, 2 pair gives us an 8. 9 can't go there.
The tip of the thermo in column 7 has to be a 5 because it's got to be larger than 4. It sees 6, 7, 8, and 9. The 8, 9 pair in row 5.
So that's what, 3 and 7 left over. This 3 tells us that way. And then this one gives us 2's here, 1's there, 9 and 2 here, 5 and 9 down here, 6 and 3 because of that. What's left in here? I need a 7, which this says it's neither of those. That's a 7. I need a 9, and I need a 6. Wah.
Secret box 7.
Get rid of all my lines. Go away, lines. I wish there was like a clear line button. There might be somewhere, but I'm just going to leave it alone. I will allow it to exist if I am bad at mathematics. All right. Chip Sounder says the secret of box 7, and the secret, if you watch Cracking the Cryptic, is the thing that Simon only shares with his favorite people. Luckily, I am one of Simon's favorite people, and I know the secret. And that secret is that the sum of any row, column, or box in a Sudoku puzzle is 45, because the digits 1 through 9 add up to 45. If we look at this box 7, knowing that it's 45, if we subtract out the 24, and we subtract out the extra 17, we are left with, so that has to be a 1, 3 pair. This 3 tells us which way it goes, and also the 1 here. And then that tells us we must have 4, 6, and 7 remaining. This one isn't a 4, that one's not a 6. And where else do we go? No, across row 4, I think. 6, 8, 9. 8, 9, and 6. And 6. Actually, this one has to be a 6, because to finish the column, we need 6 or 9. But this 9 tells us this one's a 6. So that's going to finish those 3 off.
To be able
Let's
to finish that cage that goes from box 4 to box. It sees, let's see, it could be a 1 or a 5, I guess.
Yeah, I'm not sure why there's all of these. I'm just going to try and get that to collapse there, because there's too many things it can be. But you said 1 or 5, so that's all it could be. 1, 4, 5, and I think there's something else missing. An 8, maybe? 5 and 1. Yeah, this one sees the 8 over here, and the 4 from there. And then these 3 are going to be Um,
4, 5 is 7, 9.
4, 5, then neither of those are 9s. And actually, that one has to be a 9 because of those there, this one, and that one. So that's the one spot a 9 could be. 4, 5, and 7, 1, 4, 5, and 8. So let's actually go ahead and do these columns. Chip Sounder said no stipulated total, but the digits not repeating came in handy. Yep.
1, 3,
Because
and
I think the
7.
3 did the 3, 7 here, but 1, 3, and 7. 7's there, 1 is there, 3 is there. That's a 5, 5, 4, 7, 8, 1, 4, 5, 4, 6, 7, and then I still need a 5.
6.
I need a 6 and I need an 8. 7 is gone, and this is on a thermo, so that's an 8, that's 9. 4, 8, 9, 9, 8, and 7. And we're done. I don't know how long that was sitting there. But yeah. All right. And we are 9 minutes away from our ending point, so I think we're going to go ahead and end just a few minutes early. This was a good set of puzzles from Chip Sounder. But with that, that is going to be it for today. So anyone who watches this back, thank you so much. Make sure to like, comment, subscribe, all that fancy YouTube engagement stuff. If you want to see more content on the channel, that is, make sure to ring the notification bell. And it's going to be Mondays at 8 p.m. Eastern Time for Sudoku, Wednesdays around 4:30 p.m. Eastern Time for single-player games. Currently, the Final Fantasy VII Remake. We are almost done on all of the content for the main story, just a couple extra cutscenes and little things. And then we'll do the Yuffie chapters on hard mode, and then we'll be able to go on to Rebirth. And then on Saturdays at 7:30 a.m. Eastern Time, we are playing the buggy game of The Ascent, which I'm having fun with the actual gameplay of it. It's just the game's not super stable, so it crashes occasionally, which is a little frustrating. But as long as we keep our save files, I think we'll be good to go. But yeah, over the next couple of weeks, I will probably be streaming a little bit more frequently. So look out for random streams that are not regularly scheduled. But with that, that should be all of the things. We will see you next time.